Well, how do we figure out what those equilibrium constants are? The most direct way is to measure the concentrations of the reactants and products when they are at equilibrium. That's much easier said than done, but here they've done it for us. So here we have H2 plus I2 in equilibrium with 2HI. And they're saying, suppose that we have these concentrations at equilibrium at this temperature, calculate Kc. The temperature here is just specified because you have to specify the temperature with equilibrium constants because they change with temperature. But we don't need it in the equation at all. So it's helpful to first write the expression without the numbers. So we have high squared over H2 times I2. And then we're just going to plug numbers in. So HI concentration is 0.78 molar. So we have 0.78 squared divided by concentration of hydrogen times the concentration of iodine. So 50.28, we call that equilibrium constant is 50. Did I screw that one up too? Good. Any questions?
This is an example of where the units all cancel.
This is well, the units would all cancel, except they cancel anyway, because technically they are ratios. Yeah. Let's make sure I didn't miss anything. So here we're looking at that same reaction that we just calculated the equilibrium constant for. And so here we have some sets of initial concentrations, starting out with different amounts, sometimes reactants present, no products, sometimes products present, no reactants, and combinations of various things. You let it go to equilibrium, and then you measure the concentrations. The concentrations are different, right? Up here, the reactant concentrations are both the same, and here as well, but down here they're not the same. When we plug those numbers into that equilibrium constant expression, it always comes out to the same number. It's constant, right? At a particular temperature. Equilibrium constant is the same regardless of initial concentrations. We can also calculate the equilibrium constant if we know what the initial concentrations are and we know what the equilibrium concentration of any one of the reactants is. This is a more reasonable thing to do instead of trying to measure the concentrations of all the products. We can deduce the missing concentrations using stoichiometry. So here, if we have an initial concentration of A being 1 molar and B is 0, and we measure at equilibrium that A is now 0.75 molar, we can look at, well, how did A change? Well, it decreased by 0.25 molar, right? When A goes down, B goes up, and then we have this factor of 2. If you're not careful, it's easy to do the wrong thing, right? If you're multiplying, you're supposed to divide or whatever. So this change is 0.25 molar of A. And I'm going to have let's not say molarity. There's 1 mole of A for every 2 moles of B. Because this molarity here, that's moles of A per liter. So if you find yourself mixing these up, just use a little mole ratio there. So the change in B will be plus 0.5. And then we can look at the initial and the change and say, well, the equilibrium concentration is 0.5. Then we can calculate the equilibrium constant, because it's going to be B squared over A, and that's going to be 0.50 squared over 0.75. Okay? Any questions? This kind of stuff is also what that worksheet 0 was trying to get you to think about.